Hi, everyone. My name is Bakunga Bronson, and I am one of two leads in the Geo Regional Africa group. The other lead is Kato Stephen, who is also on the call. And I'm currently studying a Master's of Computer Science at University Technology Malaysia. My interests are in fine-tuning large language models and trying to make AI adapted to African settings. As part of the community, as I already mentioned, I lead the Geo Regional Africa group. And then if you're not familiar with Cohere Labs, or for those who are joining for the first time outside, Cohere Labs is Cohere's research lab, and that seeks to change where, how, and by whom ML research is done. And our community is a space where researchers, engineers, linguists, social scientists, and lifelong learners connect and collaborate with each other. So you can just learn more from our community by checking out the community blog and also visiting cohere.for.ai. I'm just going to put that in the chat. And finally, I think it's time to also present our guest today. And our guest today is Azeez Saheed, and he's an ML engineer. And so Saheed is a first-class mechanical engineering student with experience in building real-world machine learning applications suited to Nigerians. And Saheed recently released YarnGPT, which is the whole point of this meeting today. And it's an open source text-to-speech model trained in Nigerian languages and accents. And he has won various prizes. I'm sure he'll talk more about that in about 5 major machine learning hackathons in Nigeria. And so today's session, we're just going to go through his technical background, the idea, and how YarnGPT came to be, how it works, the process of gathering data, and just building the model. So with that, I think Saheed can take it over. The stage is yours.
Okay. Yeah. Can you hear me? I just want to confirm that.
100%.
Okay, thanks so much. So can you also see my slides on the screen?
Yes, 100%.
Yeah. Okay, so my name is Azeez Saheed. I'm a mechanical engineering undergraduate at the University of Lagos. So I'm here to talk about YarnGPT. And let me just explain the name YarnGPT. In Nigerian pidgin, to yarn means to talk. That's the purpose of this yarn in the name. And GPT is from the popular pre-trained transformers, generative pre-trained transformers. Yeah, ChatGPT. That was where I got the GPT. So that's how it became YarnGPT. And YarnGPT is basically an autoregressive text-to-speech model for Nigerian languages. Right. So this the table of contents, things I'll be discussing. Then after that, you can now ask questions and I will answer them, right? So who am I? My name is Azeez Saheed. I'm a mechanical engineering undergraduate at the University of Lagos. I might be interested in how is the mechanical engineering undergraduate doing machine learning, but it was something I found myself doing when I was in my year 1, found myself learning. Then COVID came, I wasn't doing anything. So I just found myself on that part, trying to build AI solutions. And thanks to Paul for giving me this platform to be here. Paul is actually a great guy. He also does competitive machine learning. And that was how we met. We compete on Zindi.Africa. Zindi Africa is Africa's largest competitive machine learning platform. It's like Kaggle, but for Africa. So that was where I used to compete. I used to compete in competitions there a lot. And that was how I met Paul. That was how I met Paul. Paul is a great guy. So what do I currently do? I work as an AI engineer at Awari. And what Awari does is we are trying to solve Nigerian AI problems and Africa at large, because once you can replicate something, Nigeria can do it in AI. So that's what I do. So beyond working there, I also love doing personal projects and putting them out there. So one of the projects YarnGPT, this is actually my most popular project right now. So it's YarnGPT I'm going to talk about in this meeting. And there's also NigerWeb. NigerWeb is basically a large data set for a large web page data set for Nigerians. Something I just did and put it out online. And Screenshotter. Screenshotter is basically a screenshot bot that helps screenshot tweets. It's kind of like a big bot currently. It's kind of like a big bot currently. I think it has about 180,000 followers on Twitter. Yeah, it's something I built in my free time. So beyond working as a professional, I personally believe in open source, because it's in open source you get to learn and share ideas and meet cool people. I'm also proud about Cohere. I know a lot about Cohere. Like they've been building open source model, and Cohere is something I'm actually interested in personally, the community and their product. So that's about me, basically. That's majority of everything I can remember about me that I need to say. So what is YarnGPT and why did I create YarnGPT? So YarnGPT is basically a text-to-speech model. But what's special about YarnGPT is that it's trained in an autoregressive manner. Like the way your ChatGPT works, it basically predicts the next token. Like that's the same way YarnGPT works. So and what makes it special is that it was trained on like Nigerian accent and Nigerian languages. A lot, there aren't so much models tailored for that purpose. And even the models we have, most of them are not open source. So why did I build the YarnGPT, right? So prior to YarnGPT, I was just a guy who had a small job trying to like gain access to opportunities and trying to like solve African problems. I understood the fact that to gain access to like more jobs and more opportunities, I need to solve problems that are more important, basically. So that was what motivated me to build YarnGPT. I'm searching for opportunities. I want to make myself known in the AI space. Having AI knowledge is good, but it's not just enough. You have to like build it to you have to like solve practical problems that affect real world people, basically. So that was like the motivation for YarnGPT for me, right? Can you still hear me? I want to confirm that.
100%. I'll let you know in
Okay.
case anything
So what
happens.
makes YarnGPT special? Basically, YarnGPT is a 360 million parameter model. I should have added it in the slide, which is quite small for an autoregressive model, right? And it was trained for a relatively cheap model. I spent about $60 on the model, right? And $60 is quite a lot from where I stay. From in Nigeria, $60 is quite a lot. But like compared to the amount that was spent on like model, that I always spent on like model on this size, YarnGPT was made of relatively cheap. I basically trained it on Google Colab. And I wrote a lot of the codes on my phone too. Power issues, right? So like that's what makes YarnGPT special. Trained on Google Colab. And also I use Google Drive a lot. Because when I was web scrapping, the data I got, I saved a lot of them on Google Drive. Right? Hugging Face and Google Drive, basically. And yeah, also it was trained on scavenged data. I'm going to explain on this later, but it's not the conventional data that you use to build models like this. Because normally if you want to build model of this type, you have to like prepare high quality data. I personally didn't annotate any data myself. I basically just scavenge for data. I'm going to extend that data, and it's auto-regressive. There are a lot of architectures for text to speech, but they are not so much auto-regressive models. Right? I don't think auto-regressive is like the number one choice when you're building a text to speech model. I'm not sure, but I don't think so. And I use CTC alignment at some point. Oh, I was supposed to add something on CTC alignment on this slide, but I would like when I'm done, I'm going to expatiate on that. Right. So data sources basically. And I said something about scavenged data. So from a Nigerian point of view, a Nigerian client, we don't have so much Nigerian data set online. We have some data set online, but they are not so much as I would have loved to. So basically, I had to source data from movies. Basically, I found a way to like download movies, right? Extract their subtitles, extract their audio, and extract their subtitle file. And their subtitle files have like timestamp that shows where each particular transcript is said in the audio. So I used FFmpeg to basically extract the subtitles and extract the audio that corresponds to that subtitle. Yeah. So that was what I used. And yeah, I also there's some data set I have that I didn't have their transcript for. So I basically used speech to text model, ASR models, to basically transcribe them. And one thing you should know is ASR models are not 100% accurate, right? ASR models are not 100% accurate. So basically, me using ASR model to transcribe a model that I want to use between a speech to text model wasn't naturally ideal. Almost to me, it wasn't ideal when I was actually preparing that. But like, I did have no choice. I wanted to do the project. I just wanted to see how it was going to perform along the way. Also, I used some open source data set, and credit to the open source community. There are data set like AfriSpeech. I think there's a big one now called Niger Voices. Yes, that I later found along the way, right? So credit to them, because I am sure the addition of open source data set are of more quality to the scavenged data set I had before. I'm sure it improved the quality, although I can't say to what scale, right? Unless I perform the experiment with or without the open source data set. But thanks to the open source community, and thanks to everyone who like build projects and try to like open source them, right? So the audio codec used basically. So another something I want to emphasize is auto-regressive models. They were trained on text basically. The base model I used was trained on text. So they basically predict text tokens. You have a tokenizer that converts text to tokens, and the model basically predicts the tokens. That's how auto-regressive models work basically. So it's those tokens you now convert to word. But because I wanted to add like audio to this auto-regressive model, I need something that can convert like audio, which is continuous, to like tokens, which are discrete tokens basically. So I used Wave Tokenizer. Wave Tokenizer was a audio codec that I found online, and it reproduces high quality audio, and like the amount of tokens it produces is somehow low. So for example, it's a 1 second audio, it produces 75 tokens for that. That is quite large when compared to text basically, but like this was one of the best options I could find at that time. So I just went with it. So there is Wave Tokenizer. Credit to them, to the people who built Wave Tokenizer. I really didn't go deep into the maths of how the audio codec work. That's something I'm trying to learn now. But because I just needed it, I just took the model and I worked with it basically. And there are also many audio codecs. There's Snack, there's Bicodec, there's B codec, there's Sound codec. I think Sound codec was like the first paper that introduced something like this. So there are many. I just chose this because I saw that the conversion is not so bad, and also the amount of tokens per second is 75. Other models are actually quite more than this. Like I feel like this, as at then, this was like the lowest I could see, and also in terms of quality, right? So model training basically. So I said the model I used is an auto-regressive model. So I used the base model, small LM2 360. It's actually a model from Hugging Face, which was trained on text entirely. It was trained on English text entirely, right? And the reason I chose this model basically as my base model is that this model was like, it had the highest, according to their benchmark, it was better than a lot of larger models, right? That was why I selected it. But like in hindsight now, after reading like a couple of papers, I saw that the fact that a model is performing very good on text doesn't really mean it will perform when you add audio functionality to it. I read a paper, but as I then, with the knowledge I had, that was why I used small LM2 360. It's a 360 million parameter model. They have this family of model have model of many sizes. There's a 135 million and there's a 360 million. There's a 1.7 million. The reason I didn't use the 1.7 million is because I didn't have enough compute to train, basically, and also I didn't have large enough data to cover a model of that size. And the reason why I didn't use the smaller version is that my intuition just told me that a smaller model might not perform so well. And since this is not too big, I decided to go with it. Although you never can tell if it had used a smaller model, you never could have tell of performance. But generally, a larger model always leads to better performance. That was why I went to it. So basically, this model had about I think the embedding layer had about 49,152 text tokens. Like the embedding layer shape was 49,152. That's the amount of is it rows? Amount of rows in the embedding layer, or maybe columns, depending on how you look at it. So I extended it to include audio tokens. And something I must mention is the audio codec has about 2,040 something unique tokens that it could produce, right? So I just extended this model, like the embedding layer, I increased it basically to 49,152 plus. I think I added 248, yes, to maybe make it longer. And those new layers in the embedding layer represent the audio tokens I newly added, right? So yes, also in terms of special tokens, I added some tokens to talk about, to characterize the timing of the time at which a word was said in the model. I'm going to explain this when I finish the slide, right? So also the model was trained in the same way you train normal auto-regressive model. So in fact, I didn't really have a lot of experience training an auto-regressive model. Prior to this, I really didn't have a lot of experience. I just basically went online, saw that, how can you train an auto-regressive model? And I found approaches to it. It's basically, you give your model with your input tokens and your label, then you calculate the loss, then you get the loss. After you get the loss, you perform a backward step, and then you update the way. That was the same way the model was trained. The same way you fine-tune a model on a text data set, that was the same way the model was fine-tuned, right? Also, I have to use gradient accumulation, right? Because I had to use a small batch size because I was using a smaller GPU. So I had to like go with small steps. And when I get like a large step, I will accumulate the gradient together and update the model weight. And I also used an A100. A100 is, I think this is the largest GPU offered by Google Colab currently, right? So that was what the model was trained on. I think it's currently cost about 800 and 8 point something Google Colab credits per hour, right? Which was somehow cheap. Prior to this, like the last time I used an 800, it was 16 point something. So when I now came back to this project and I saw that, oh, it was 8 point something, it felt cheaper to me. And I also used Google Colab and Google Drive, right, to train the model. Basically, all of the data was basically trained on, all of the data was basically stored on Google Drive, which made it so I didn't have to pay for any extra storage. And because I was working with like a large amount of audio, basically downloading audios, I use Selenium to download like videos. Downloading videos take a lot of space. I would probably have needed to pay for cloud hosting to probably save that large amount of this. So I just basically pay for Google Drive, their pro subscription, right? So I have like 2 terabytes, and that was like large enough for me to train whatever I wanted to train. And I used Google Colab. Also, I used a constant schedule with linear decay at the end. And the reason why I use this was because I was using Google Colab. I didn't have this, like I wanted to always stop the model at checkpoint and continue training. If I had used like a cosine schedule, it would have been difficult for me to like undo that. But like with a constant schedule, anytime I'm coming back and I'm training, I know it's still the same weight I'm using. And another motivation for this is this small LM2 I mentioned I used, right? It was trained with the same schedule. So I just thought in my head that, oh, let me just go with it since it's worked for them. And yeah, since it's worked for them, I just went ahead with it. And I also read a paper where they mentioned that a constant schedule with linear decay, a constant schedule with linear decay already like they performed an experiment that confirmed that it already like equates to using like a cosine linear rate schedule, basically. So that was why I went. So this is like the special things in the model training. Maybe in the question and answer phase, I'll mention more. Okay, so that's all on training the model, right? So after I trained the model, basically I needed to like tell a story about the model when pushing it out, right? Because building a model is good, but like you need to like put the model out. So I made the model open source, and I think that's one of the things that like that's one of the things that haven't given me the platform to be speaking on this call, basically. So like I recorded a video where I talked about the model functionality and I added some stuff to it, and I pushed the model on Hugging Face and I tweeted about it. I also made a LinkedIn post about it, and like a lot of people in the community have given me like good feedback on the model. The model is not perfect 100% yet, but like by pushing it open source, I've had like a lot of crazy ideas from people in the community like that I couldn't have maybe thought of on my own, right? Also, like another thing I learned from this process is just make your model open source. And why is that? It helps the community. When you build something and you put it out there, it motivates other people to want to throw that line or to want to push something stuff. And it also makes people talk about your project better. And also, when the model is open source, you as a person, you are smart, right? But like when you put your model out there, a lot of people will contribute ideas to this model, and that will push the project and make it better. And also, young people can learn from it, basically. Because imagine small LM2 wasn't open source, I probably wouldn't have been able to like do this model, right? And also, something I learned, like this model was basically like sourced from open source project, basically. Like a lot of what I did with this model were open source. I just basically went online, saw like an open source approach, I implemented it, and like that's how it works. Thanks to open source, basically. I always give thanks to open source.
Can I
Okay,
just
so
say?
let me talk about the hello.
Can I just say? I actually was going to mention the LinkedIn post because I think that's the
Yes,
first time many of the
yes,
people on this call actually saw you, and so I think that was actually a
yes,
very interesting thing. The fact that you put out the video and
yes.
everyone could actually see the fruits as opposed to
Thanks.
the technical jargon.
Yes. I want to share something. Thank you so much. I want to share something. Like I said something about CTC alignment. I want to emphasize on that better. So I'm trying to like load up something. As soon as it loads, I'm going to share my screen.
Sure thing.
Yes. Give me a
And then-
minute.
In the meantime, I just also
Hello, can
want,
you hear me?
yeah, I can hear you. In the meantime, I also just wanted to say the ingenuity that went into this project is actually very, very intense. Like using Google Drive, using your phone for the coding, you basically used everything that was at your disposal and you just made it work.
Yes. Yes. Thanks. Yeah, I use my phone, but like I actually had to code some points on my laptop. But because of like power issues, when they take light, I'll just open Colab on my phone and code. Like it was, and because like I was motivated about this project, like I just wanted to like make it work because the model actually like it basically took a lot of my time, right?
Yeah.
And when you are halfway into something, you want to like see to the end and make sure it gets done, right? So I'm going to share my screen now and mention something I said about, and like reemphasize something I said about alignment. Stop presenting. Okay. Contact.
Yeah, if you have any questions, you can leave them in the chat space, and then we'll come back to them after Saheed has finished, the clarifications that he wants to make.
Okay. Can you see my screen?
Yes, I can.
Okay, so let me just explain. So basically, most text, like thinking of a text to speech, like a text to speech model in an auto-regressive manner, basically, the first approach I first tried was basically give the model text, it predicts speech, right? That was the first approach I first tried. You give the model a text, it predicts speech that corresponds to the text you put in. But I actually tried that was the first attempt I tried and it didn't work so well, right? So I came across this approach from Outtake TTS. Let me make my screen bigger. Okay. Is my screen more bigger?
Yes, we can see the
Yes.
the
Okay.
tokens now.
I saw this approach from Outtake TTS. So it's basically like a special kind of crafted prompts to train an auto-regressive manner, like to train a model, to train a text-to-speech model, right? So instead of giving the model the text and ask it to predict speech, that corresponds to that text basically. So what this approach does is you first give the model the text, like this sentence basically, and it first splits the sentence into words. He does that. He does that. That's amazing, right? Like it's basically splits the input text into like words and separates them, right? And it first gives the model that. Like it gives the model each of the words, but it separates them with like a separator token, right? These are the words. For example, does is the word, that is the word, he is the word. Like these are the words. So these are the words that comprises the sentence. Then after that, it predicts the first word again. That's how this model was trained. It predicts the first word again. Then predicts the time token for that first word, right? Then it now predicts the audio that corresponds to that first word. Then after doing that, it predicts the second word, predicts the time token for the second word, then predicts like the audio tokens that correspond to that second word. So what I observed with this approach is that like the fact that you are predicting the word again, it gives the model more guidance that whatever you are predicting, the audio you are predicting now corresponds to this word. And when it's done with that, it predicts the second word, and it predicts the audio tokens for this second word. This is like an approach. This is like a crafted prompt I observed from Outtake TTS around the train their model, and I'm sure it improved the performance because instead of giving the model text and just the full audio, basically, I feel like this approach basically helps the model because you know that what the model is predicting audio for now is yo. After that, the model goes to the second word, predict the second word, predict the time token for the second word, predict the amount of audio, like predict the audio tokens for the second word, does that for the third word. I think this helps the model performance improve, right? So this to create my training data set in this format, I had to use CPC alignment to basically get the words, get the audio that corresponds to that word, move to the second word, get the audio that corresponds to that second word. So it was CPC alignment I used to align like each word to the audio that corresponds to it when training the model. So basically, if you want to predict something to the model, you just have to give the model a prompt like this. Then the model by itself would go to the first word, predict the time token for the first word, predict the amount of. So I think this improved performance. But another thing I've observed like later on is that there was no need to separate this using a separator token, right? That's one thing I've observed. Like I noticed later, like there's really no need to separate this a separator token, right? Yeah, and like because I used like the base model I used was trained on text. I feel like if I remove this, like if I remove these separator tokens, the full statement I'm going to be giving into the model will resemble the way the model, like the model is going to be saying sentences that probably it was trained on while it was initially trained. So that was what I wanted to clarify. And I feel like this approach helped the model performance. I'm sure it does. Although like I didn't perform like an experiment with or without this prompt to know to what extent, but I'm sure it does. So those are the things I want to say that I can remember now. So maybe if you have any questions on some parts I didn't touch, let me check the question, this thing, if there are questions.
Yeah,
Okay.
and maybe just to clarify, there is you can put up your hand as well, and just give you a question like that. There's no if you want to speak,
Okay.
I'm sure some things can be expressed like that. And yeah, maybe just to say before we close, before we go into the questions, thank you to Paul, because Paul is actually the one who was able to set this up and help us get in
Yeah,
contact
thank you
with
for.
you. So
Yeah.
yeah,
Yeah, I also apologize for not being available yesterday. I had an event I had to be at. Like
that was
it was a
understandable.
work event, so I couldn't just. Yeah.
It's understandable.
Okay.
So
Okay.
please, questions, guys. If you have any questions, I
Okay,
think
I've
there's
seen a
one.
question. Did you face any runtime issues with Google Colab? In a way, yes. There were two major issues I faced, right? The first issue was that Collab doesn't run beyond 24 hours. Like, although I have to do Collab Pro Plus subscription to be able to like get that 24 hours, like runtime basically. But when anytime is beyond 24 hours, your model shuts down. So, and wherever you stop that doing training, your model training is going to stop. And I wanted to train the model for like a longer period than 24 hours. So that was like a limitation I faced. So basically, I had to like time the model such that it was going to stop at a checkpoint before like model training. I basically had to use pre-epoch so that the model training was going to stop before 24 hours. So I will now continue the training again. And another issues I faced is because the A100 is quite large for my standard, but like if I need at some point I needed to train the model for a longer sequence length, and an A100 couldn't cover for that, right? So an A100 couldn't cover for that. So I basically had to reduce the sequence length I was training the model for. That was another issue I faced. Also, in terms of runtime, I think if you pay for Collab Pro Plus, right, you get a 24 hours runtime, which is very good. Like imagine having your code, letting it run 24 hours and going to do another thing. It's very good, actually. So, and it was Collab Pro Plus. So I didn't really face much issues with uh, runtime in that sense, right? So those are basically the issues I faced with runtime. Yeah, thanks.
Also, maybe just to also touch on the runtime issue. Um, for example, do you think that okay, now that you've done this before, do you think that
Yes.
there's anything that you would have done differently now that you've sort of done these experiments um more times? Do you think there's anything you change on the compute side, anything on the data side?
Okay, so in terms of what I would have done differently, like I mentioned earlier, I think when training, I would have removed this, like all these text separators, I would have removed it, right? That's one thing I noticed that I would have removed it for sure. And also, maybe I would have gathered more data because at some point I was tired of the amount of data I got, right? So I just stopped there. Maybe I would have gathered more data. Maybe I would have, yes, gathered more data. And more data would help me to train like a bigger model. Also, in hindsight now, I would have used small LM360, right? I would have probably used this Quen, the 0.5 billion version of Quen. I would have used that, right, to train. Yes. Also, what could I have done differently? I think those are like the things I could have done differently when training. Use a bigger model and maybe remove these text separators, right? That's something I would have done basically and get more data, like more data, right? Yes, actually. And also you can always, like, data is always a major issue. But like if you can get more data is good. So if I can get more data, it will surely improve the performance. Yeah, so that the things I would have done differently. I remember when we were training a text-to-speech model again, maybe I wouldn't have used this architecture. I would have checked out some other architectures like style TTS. Maybe I would have checked out an auto-aggressive architecture, because the limitation I observed in this model is that like the latency is poor, right? It's like the amount of time it takes to respond is somehow is relatively poor compared to other model types. That's something I observed, but that can be solved by using like another inference. Like it's poor on Hugging Face, right? Maybe with better attention strategies like page attention that like VLLM is using. Yes, maybe that solves the problem basically. But like I would have used a model like a different architecture, a more aggressive approach. But like I'm glad I did this. Like I'm glad I used this approach. But maybe that's another thing I would have tried. And maybe in the future, that's another thing I'm looking to explore. Use maybe another architecture and just see how it performs right.
Yeah, I'm actually glad that you mentioned style TTS, because I think that's where a lot of people started to gravitate towards. And that's why I thought that you probably already have like a version 2 already planned out, and it seems like you already do because you already have style TTS in mind. But yeah, the space is very interesting. I think right after I saw your LinkedIn video, that's when we got all these other, text to speech models, Canary and
Yes.
Orpheus, and so many of these.
Obvious, yeah.
Yeah, all of these new text to speech models that have just come out. But I still think that this is still something that is a major milestone in terms of being able to be reproduced and usable.
Yes.
I think it's time that we go to the questions in the chat. I don't want to take up. I don't want. And also, if you want to raise a question directly, please put up your hand. But Alban does have a question, and he asks, "Oh, we already went off of that." And then Paul has a question, and so he asks, "How easy would it be to extend the supported languages, and what's the process like?"
Okay, so basically, extending it to other language shouldn't be difficult as long as you have data for that language. I think in my GitHub repo here, there's like a notebook that covers like preprocessing, like how I preprocess the data set. So it's basically just get your own data set, go to this prepared data set and perform it for your own data set, right? I have to update this code. I don't feel like, I don't know why it's not working. But like I have this notebook. Let me search for it here. Like basically just preprocess the data set to your, like for your own language in the same way I preprocess this. That was why I released this publicly, but I don't know why it's not showing.
It
Right.
works. It's
So
just
basically
that.
Hello? What do you say?
Yeah, no, it works. It's just that I think maybe there's an issue showing, but when you go on the code side, you can see that the actual code is there. So I don't know what the problem is. I think it might be a GitHub issue.
Okay, so like this is the notebook I used to basically preprocess the data sets, right? So this is the wave tokenizer I used, right? And this is the CTC alignment class. I wouldn't want to go into the explanation in depth here. But like this is the code. I'm sure it shouldn't take much effort to like, I feel like if you just run it from top, it's going to run by itself. So basically you just have to like load your data set in. And this prompt processor, you convert it to the language you want to prompt for, right? Then after that, you preprocess the data set. I think this is the function that does that. Yes, so you loop to the data set, and at every 1,000 step, you preprocess like 1,000 audios. Like at every 1,000 audios, you process them and save them to my drive. I save them to my drive, right? Then everything, I now got everything that was saved. I concatenated it to get like the full data set, right? Yeah, so that was like the process to. So I feel like you just need to preprocess it for your own language and for your own data set, right? Then fine tune the model. The same way you fine tune like the same way you fine tune a model, an autoregressive model, just fine tune it on that data set, and it will work basically. So the only thing I don't know is like the amount of like what's the amount of data you will need to get good performance. That's something I can't answer currently, but I don't think it's difficult to extend it to other language. I think it's something that can easily be done.
All right. No, that's a very good you know, that's a very good explanation because I think, the beauty is the code is like out there and anyone can run it, right? So I think that's a very nice initiative and it could be something that we could build upon. Touching on actually Paul's question, have you explored multilinguality? Maybe having two languages in at the same time, or do you think that's something that is a bit complex at the moment, given how the
Wait,
tokens are being given?
okay. So there's actually YarnGPT 2. And I
Oh,
think the second version, YarnGPT 2, it actually covers Yoruba, Igbo, Hausa, and English in one model, right? Let me let me let me just search it out. Okay. Yeah, it basically covers all the languages like in one model, right? And I think the performance of this is even better than the initial YarnGPT, where I separated one model for English and one model for local languages. So this YarnGPT 2, it covers that actually, Yoruba, Igbo, and Hausa already. So that's something I've actually explored, right? Yeah.
all right then. I think we can just share that in the chat so that in case anyone wants to
Okay.
check that
Let me
out, they can
share it.
have that. And then we have another question from Alex, and Alex says, do you plan on addition/collaboration with other African communities?
Yes, actually, I have a plan coming up. We are currently we are currently like trying to like build a better model, like a way better model, basically. Like not even in terms of like text to speech, we are trying to like build better models all around. I work at Awari. Let me share
Yep.
you a link to the place. So let me share you a link to this. So basically we are cooking like a lot of stuff like coming in soon. But although we have currently focused like on Nigeria currently, but like we are cooking up a lot of stuff, right? So maybe my free time at some point later, I'll currently like build some other open source project later, like later on during my, but currently like I'm currently working on like an in-house stuff basically.
Yeah, I think that's understandable. Um, does anyone else have any more questions? Does anyone have any specific questions? Um, I think I still have one more question. After the release of
Okay.
this, what interesting use cases have you seen for Yarn GPT so far? What do you see the community has started using this for?
Okay, you can. I had someone who built like a drug recommendation, like an AI drug recommendation system, and it used the YarnGPT. But like I don't know to what. And maybe I have to like check back with him and know to what extent he has continued with that project. But for me, the use cases I see with it, I feel like it could be used like anywhere that involves speech. Basically, you could use it in like audiobooks and all. Basically, those are like the applications where I find it. But another limitation with the model is I personally don't think like it's 100% production ready, like 100% production ready. So when there's a better improved version, yeah, I feel
Yeah.
like people will embrace it like a lot more. People will embrace it a lot more. Yeah.
Yeah, no, that makes a lot of sense. And I think actually this is the website I was going to show just now. I think if you haven't checked out YarnGPT, please check it out. And I think it's really interesting when you put it in and then you actually see the audio that comes out. Someone actually reached out to me when I posted this in a group, and they were like, I use this for creating animations. And so I was really impressed to find out that even beyond Nigeria, it's being used in use cases like that. So that's why I wanted to ask and see, are
Oh wow.
people
Maybe you can connect me to the person later on.
sure thing.
Yeah.
But that was the first thing that someone told me when I posted about it. So
Okay.
I was just really amazed to see that people are already, finding different use cases. And like you said, audiobooks, I think even advertising is very possible with something like
Exactly.
this. So just all around great stuff to see. Um, are there any more questions, guys? Last call. Okay, so I don't think there are any more questions right now. Maybe everyone's okay. Personally, I just want to say thank you for taking the time of coming here. I know it gets a bit busy, so we're okay with rescheduling. We were actually very trying to make this work because everyone was excited. I think this was one of the most um hyped sessions that we had. many people did reach out. Many people wanted the link. So I just want to say thank you for taking time and coming here and just continuing the great work. Thank you so much.
Yes, thank you so much. I really appreciate this opportunity because I've known Cohere like a lot. It's a big community. It's a community I would actually love to get very involved in, but maybe because of my timing at this moment, somewhat difficult. But it's a community I would actually like to get involved in. I think I'm on the Discord. Is it Discord or Slack? I'm on the Discord. Yeah, I'm on the Discord. Although I don't personally like discuss a lot, but it's something I would love to do like in future because I see like a lot of opportunities with Cohere. Yeah.
No, sure thing.
Thank you so much.
Stephen,
Yes.
please.
And special
please.
thanks to Paul for like processing everything.
Definitely.
Oh, someone has raised a hand.
Yes. Are you hearing me?
Yes, I can.
Yeah. So I'm the colleague with Bronson, and I'm the one who reached out earlier to Paul,
Okay.
so that Bronson can host this session. I'm grateful that Bronson has done a good job so far with the first sessions, and grateful that you've made it. You know, we are open to having people who have great work like you to come to the Cohere. Cohere is not only a community, Cohere Labs. It is a sort of a research-based organization. You have a chance to work with the leading researchers in the world. That chance is there. Bronson can verify that. So the Discord, we try to make it a bit engaging, but still we're facing challenges. But if you have anything you'd want to share, Paul, if you want to have a session too, you're free to reach out to Bronson or me, and we host you also and see your work. Because I had in the beginning, Paul has been doing machine learning, and I would also want to thank Paul, again Saheed and Bronson. I think that's all I wanted to say. That we are open arms. We do want people to come.
Yes, thank you so much.
All right. I think that is the best way to close it out if there are no more questions. Short, sweet, straight to the point. We got everything. Thank you everyone for coming, and thank you Saheed again. Do you have any closing remarks for us?
I don't have any really major closing remarks. Just like basically thanks to the open source community for putting stuff out there, because like this project is like a build up of a lot of other people's projects and ideas. Basically, just thanks to everyone, to the open source community, and like I don't say like let's keep building open source product. Basically, thanks.
I think that's the best way to close it out. All right, thank you everyone for showing up today, and have a great day ahead.